my name's Todd Ellis. I got my undergraduate degrees from Penn State University, and my degrees were in physics and meteorology with a math minor. My research right now, my master's research is still, so it's a preliminary to what I hope to be getting to. And essentially what we're dealing with right now is looking at satellite databases of the cloud amount in the atmosphere. You know, looking down at a certain region and saying, okay, this is 75% cloud or 85% cloud or those kinds of measurements. We look at those databases and realize that there are long-term changes in those of kind of an abnormally large degree. Some of the data sets say that there is a 4 to 5% change in the cloud amount over just 12 years, 15 years. And we look at this and say, is that really happening? And if it is this a signal of climate change or not? So my research has really been taking a look at these cloud databases and trying to find out if those long-term changes are manifest in other data sets. So we're looking at other related cloud satellite measurements. We're looking at how the atmosphere responds to clouds and seeing if there are changes in the general circulation of the atmosphere that are either responding to or driving changes in the cloud fraction. And by answering these questions, we kind of hope to do two things. First of all, we want to know if there is really a signal of climate change, a large one over 15 years. And the second question is, if this is real, are the climate modeling communities who are using this data set to verify their work, are they capturing this variability? And as I got into this project, it became obvious pretty quickly that the cloud database is wrong. There isn't this large trend. But because it's present in the data, the cloud modeling community is now using this data to verify their work, and the data they're using to verify it may not be correct. So my work is a preliminary. So, I'm using my results sort of to prove that this data set isn't right, and then we're hoping to find some way to correct this cloud data set so that people are using the right information. My advisor at the moment is Graham Stevens. Works primarily with satellite meteorology and remote sensing, and will be the PI for CloudSat, which is the new satellite going up hopefully next year. Delays, you never know. The reason I selected him basically comes back to the idea of needing freedom, academic freedom to kind of explore what it is that I wanted to study. And talking with Graham, he is very much a big picture oriented researcher. He's not asking specific questions that are so specific that you kind of get pigeonholed into one thing. He's asking very broad questions about how does the Earth interact with its climate? How does the satellite meteorology aspect, how can we measure how the climate's changing with that? And they're always very broad and big picture questions. And so in talking with him when I was first exploring coming to CSU, he really made me feel like whatever question it is that I ended up exploring would be one that had broad-reaching impacts, not just in the atmospheric sciences, but also in the community at large, the world, politics, things like that. These are important questions that need to be answered for policymakers, for environmental scientists, and basically anybody who's interested in how the Earth system works. So I was comforted ahead of time knowing that whatever I worked on was going to be a question with important impacts on society.